right. Now that I've lost all faith in Linux again. No, I'm just kidding. I love it. This never happens, guys. It works every time, I swear. But Murphy's Law, so I brought the Chromebook, which is also Linux, so it counts. All right. So my name is Ben Porter. Going to talk this morning about Elixir and Phoenix, kind of specifically for people that are familiar with Ruby. Can you guys hear me okay? Yeah. Sweet. So this is a little bit about me. Yeah. I was going to make a joke about how Matt stole the Ruby source code from me, and I just wussed out, so I'm not going to make that joke. But yeah, if you want to look me up on Keybase or email or Twitter, I'm at freedom_Ben because somebody beat me to the freedom Ben, so there's lack of coherence in there. But yeah, feel free to reach out because I love talking to people. So. All right, let's jump right in. So what is Elixir? So Elixir was created by Jose Valim, and for any Spanish speakers who think that I just Englished the name Jose, he's Brazilian, so it's pronounced with a J, so shall I throw that out there? Unless there's Brazilians who can correct me and tell me I'm wrong. It's always a risk. Anyway, he was a Rails core team member from early 2010 to mid-2014, and he received the Ruby Hero Award. So the reason why I mention that is that Elixir was very much influenced by Ruby. And you can definitely see that when you start looking at the language itself. So I mentioned Elixir was inspired by Ruby, but it runs on the Erlang VM. So if, like me, you have previous experience with VMs, mostly Java, and you have poor memories of wrangling the JVM, the Erlang VM is a lot better. It's a lot different. Not to bash on Java, but and there's also a very good reason why the Erlang VM exists, and it's the actor model. So the actor model is out of scope for this talk, but it's kind of a different way of approaching concurrency, and it's definitely worth looking into. Going to get rid of this little notification down here. There we go. Okay, so Elixir is more opinionated about how you write it, which can be good and bad. It definitely leads to more consistent code that, in my opinion, is much easier to reason about. But obviously, you lose a lot of flexibility. So I tend to think of this as more of a good thing when I'm working with large teams and I'm reading a lot of code versus writing. If I'm writing the code, I prefer the flexibility and power of Ruby. If I'm reading a lot of code, sometimes I'm not super hip on them having the powers to do crazy metaprogramming. If you've ever had a bybug prompt that starts and you look for the source and it says no source found in Ruby, that's a good time right there. So a lot of people refer to Elixir as a new Ruby and Phoenix as a new Rails. I'm not really a huge fan of that expression, although it's not, I guess, technically incorrect. But so the question then would be, why do we need a new Ruby and a new Rails? And I think I'd start by saying I don't necessarily think we do. There's really nothing wrong with Ruby and Rails. I mean, obviously, we're all here. We use it. Ruby is still under active development. It's still getting great features. Same with Rails. They're still moving along. So there's no reason, you know, like I've seen some people in the Elixir community refer to Ruby and Rails as essentially deprecated, and that kind of bothers me because I don't think in any way that it is. It's still a great platform. But there are some things, there's some trade-offs that you make when you adopt Ruby and Rails. One of them is scaling. And I don't mean like the Twitter where they decided they had to move to the JVM or anything like that. But as long as you're writing your app well and you're following Heroku's 12-factor app principles, you can scale horizontally basically as far as you need to with Ruby. It's not going to be a problem. But when you start adding instances, that gets expensive fast. And so scaling with Ruby can be very expensive. And now, depending on what scale you reach, the added productivity of your engineers may offset that cost. But it may not as well, depending on what scale you get to. So that can be a huge benefit. With Ruby, when you're trying to scale horizontally, or at all really, you also end up choosing between essentially multi-threading or multi-process. And for true horizontal scalability, you have to be multi-process, and for any high availability, you do as well. But both of those have downsides. Like multi-threading is notoriously difficult. Even people who do it all the time and have lots of experience, they still occasionally will write deadlocks and end up with race conditions and things like that. And also, a lot of gems in the Ruby ecosystem are not thread safe. And that's a hard lesson that sometimes you don't learn until you have weird things happening in production. So it's definitely something that you should approach with caution. So most of the time, people will go with multi-process, but that also has downsides because you're duplicating a lot of memory, and there's a little bit of overhead in each Ruby instance, and so that is a bit of a downside. And you also can't share things as well. And then also, there's a lot of really cool and interesting tech that's emerging around like WebSockets and the like, and Ruby is definitely gaining some ground there, but it's a thing that's emerged later. So a lot of it is it's a framework and a language ecosystem that's adapting to new technology, which is great, and that's definitely what we'd want. But then also, functional programming in general is also really gaining in popularity, and in my opinion, that's for some good reasons, because it really can improve things for you. So let's talk about some of the benefits of Elixir. Elixir is very much known for performance, and when I say performance, there's a bit of a misconception out there. I'm not referring to raw CPU processing power necessarily. The performance is very much in low latency and things like that. If you were to compare, say, Elixir doing CPU-bound tasks, compare that to Rust or Golang or C, it's going to lose by a decent amount. But most of the time, we're not CPU-bound. Most of the time, we are I/O-bound on either the network or the file system or something else. So if you have a very CPU-intensive task, Elixir is probably not the right way to go, unless it's very parallelizable, and then Elixir really might be the way to go because a little bit of overhead, but getting that actor model that allows you to reason about your concurrency a lot better will be a very worthwhile trade-off. Elixir tends to be a lot easier to reason about because of things like forced immutability, minimal side effects, et cetera, and we'll talk more about that in a bit. But it's also a very clean language. It's very lean. And it's one of the first languages that I've ever seen where they essentially have said the next release is basically done. Like, they're not going to be adding things to Elixir, at least not in the short term. And some of the reasons they gave for that is that we see a lot of people have adopted Golang because it is such a short and easy language. You can read the Golang tutorial, and in 4 hours, you've got a bulk of it in your head. And so Elixir is kind of taking the same thing. But there's some amazing tech possibilities that Elixir and Phoenix will essentially give you for free. Things like live view. If you guys haven't heard of that, this was demoed last year at ElixirConf by Chris McCord, who's the guy that wrote Phoenix. And he demoed 60 frames per second animation being rendered on the server. Rendered on the server. I'm going to say that twice for effect. It's amazing, amazing. One of the implications of this is that it's still early days, but there's plenty of proofs of concept out there. You could potentially replace your client-side Java framework or JavaScript framework with server-side rendering in Elixir. That starts to become a real possibility with increased performance because as we're getting more and more thin clients on the front end with the client, a lot of times our server has way more processing power, so you could actually get much better performance by rendering on the back end and then just presenting that pre-rendered on the front end. So this is a GIF, which is actually a lower frame rate than the animation. So it's not going to do it justice. But that animation you see is being completely server-side rendered, sent down to the front end through a WebSocket, all using Phoenix Live View, and it's very easy to get started. That's the kind of stuff that gets a lot of people very excited about Elixir and Phoenix. So let's talk a little bit about immutability. I suggested that immutability could help make the code a lot easier to reason about. I want to give a really quick demonstration of that. So this is Ruby code. This is just IRB. And you can see we create an array, cust ages, and drop a few integers in there. And then we call a .reverse method on that array. It behaves exactly as we'd expect, returns an array that's reversed. But then we wonder to ourselves, did this mutate the original? Is the underlying array still the same thing that we defined? So we check, and sure enough it is. It has not changed. Then we decide, you know what, we've got another customer here, we need to push his age to the array, so we call custages.push. And then we have the same thought. Did this change the underlying array? It is not immediately obvious whether it did so or not, so we check the array, and sure enough, it has mutated our original. This has been a risk in most languages for a long time. fact, back in my Java days, which I don't like to talk about very much, this sort of stuff made bugs that were just insane, absolutely insane. Sometimes in enterprise Java, you got call stacks that are 70 frames deep, and frame 45 mutates your original structure. And now you've got this insane bug that you can't find. And so essentially what you end up doing is you defensive copy everything. Anything that comes into your method, anything that you send, you copy, copy, copy. That is not sustainable or scalable. It breaks down. And so at a certain point, you profile and you realize, we have a ton of memory just sitting there from all these copies. We got to reduce that. Then you reduce that, and you introduce huge bugs, and your life becomes horrible. This is something that Elixir makes impossible. It is immutable. Every time you make a change to something, to some data structure, you are getting a copy back. And it's not as inefficient as it sounds. There's a copy on write mechanism, but then there's also some things that they've done to alleviate. They're out of scope, so I'm not going to go into them. But it's not as efficient as it sounds, because that can be a scary thing to say. Anyway, so functional programming, we're essentially going to treat computation as the evaluation of functions, much like mathematics. So, traditionally with programming languages, they tend to be very imperative, and we've got some better patterns that we slap on top of there. But functional programming somewhat changes the paradigm, in that we're looking at these more as mathematical expressions that do stuff. So functional programming, you're trying to avoid mutable data and changing state. Pete Hunt really changed my outlook on state when he got up in front of the world to talk about React, and he said, and I think this is an apocryphal quote, but he basically said, state is the root of all evil. And he talked about how so many bugs, especially in a UI, in a GUI, so many bugs are the result of state and not properly understanding your state or not properly mutating it to the way that you need it to be. And so he completely changed the paradigm with essentially always re-render. And part of that was keep your state in a very focused place. State is a necessary evil. In functional programming, especially languages like Haskell, we try to pretend like you can be completely stateless, but you really can't. It's not useful. As soon as you write to standard out, you have mutated some sort of state and caused some side effects. So it's really not, the pure model is academically interesting, but not pragmatic. But we can make things a lot better by trying to stuff our state into a container or a package or a box, so that way we know where it is, and we can also behave as though our state is a series, well, like with Redux. I feel like I'm getting slightly off topic here, but you could look at state as very reproducible. You have a clear path, clear steps to get to your state, and that's something that functional programming really emphasizes. Functional programming also emphasizes declarative programming. So in other words, you're doing your programming with expressions or declarations rather than statements. So it's kind of like you should tell your program what to do and not how to do it at a higher level. At some point, you're going to have to say how to do it. But especially when you're reading code, it is so much easier to look at an algorithm and have a list of function calls that tell you what they're doing. That's a very declarative approach. And to the extreme, you probably already use this all the time. In fact, Ruby, one of the things I love about it is that it is a very declarative language. It allows very high-level patterns like that. But anytime you use a JSON or YAML config file, you're doing this. That's declarative. And it's definitely a benefit. Functional programming also emphasizes idempotency, meaning that the output of a function depends only on the arguments that are passed to the function. There's a related topic called referential transparency, which I'm not a compiler writer, but I've been told that the referential transparency guarantee of things like Elixir can allow for powerful compiler optimizations because it only needs to invoke a function with certain arguments one time. If it ever sees the same function call with the same arguments again, it can just swap the value and put it right there in line. It doesn't need to actually run the code again if it's a pure function or idempotent. Functional programming also attempts to eliminate side effects. In other words, changes of state do not depend on the function inputs. There's no global state, there's no global variables, things like that. You're not changing something outside of your function. So let's do a brief comparison of object-oriented versus functional. With OOP, a lot of times we think in terms of classes, objects, and instances of objects. We tend to really focus on state. especially with Java, they really kind of pushed the idea of encapsulation, and so that's kind of crossed into lots of different object-oriented paradigms. And so that can help. Encapsulation is definitely an improvement in that outside classes, outside code should not have to care about internal implementation details, only what's exposed. But it's still only really a half solution because you still need to worry about that object being mutated by some other part of the code, even if it's going through the encapsulated interface. So functional attempts to, so object-oriented, there's very much a focus on state. And you call methods on objects, which are essentially like behaviors. With functional, we change that paradigm. We try to think more in terms of data transformation instead of in terms of objects. Now, at first, that's a really weird thing to think of. But as I've gotten more into functional programming, I feel like it actually is a more accurate model of the real world. So oftentimes, we really are taking data in some form and trying to transform it into another. In fact, if you think about web requests, that's literally what they are. You have some request, that's the starting data, and your job as a server is to translate that request into some sort of data that you're returning, either JSON or rendered HTML or something like that. With functional, again, state is minimized and isolated as much as possible. It's the root of all evil, but it's a necessary one. So we try to keep that minimized as much as possible and isolated to the extent that makes sense. And then obviously with functional, we're still calling functions, but when we call functions, we're not invoking them on objects. They're not methods anymore. We're passing all the data that function needs as arguments, including, and we'll look at an example here in a minute, but including, like say, if the function's job is operate on a string, you're not calling string.some method. You're calling, the module literal string.some function, and then you pass the string as its first argument. So functional, I mentioned there, data transforming is kind of the approach. You probably already do this in many ways. Like if you have any experience with Bash or Unixy shells, then there's the pipe operator, which is fantastic. And that is basically the same idea. So I've got this little snippet here of some Bash code that essentially, if you have a GitLab project and you want the merge request ID, but you don't want to use the GitLab API because you don't need it, then this would do that for you. So we basically just use Git, regular tools, enumerate the branches and stuff on the remote, and then we pipe it through grep a couple times, then through awk, then through sed. And at the end, we have just a single request ID that comes out of that. Pretty cool. But if you notice, grep doesn't care about anything except its input. It's only looking at the input stream, and then it only cares about its output stream. And then the next time you invoke grep, it's not looking to see what did the previous grep do, what sort of existing state is on the system. It doesn't know or care, and this is a beautiful thing because we can chain these things together, we can reuse functions in different ways, and what you might see when you start programming in a functional way is that your functions become useful in ways you never even expected or anticipated that they could be, especially if you're writing things algorithmically. Okay, so as I mentioned, you probably already do functional things, and you may not realize it yet. But things like map and sort and select and each, and the way Ruby uses blocks, those are all things that are very much functional in nature. With blocks, you're essentially just passing Lambda functions. I mean, it's not technically accurate, but at a high-level abstract way of thinking about it, you're essentially passing around snippets of code that are functions, and that's what functional programming does, essentially. So Ruby is a fantastic language to do functional programming in. And so you can already start using functional techniques in your Ruby code. And in fact, I would definitely encourage you to. But one thing I will say is that Dave Thomas, who wrote the Ruby Pickaxe book, which probably a little bit outdated now, but amazing book if you're still interested in it. He also wrote a book on Elixir. And he mentions in there that you didn't learn object-oriented programming overnight. You're not going to learn functional overnight. So don't beat yourself up and don't feel like, oh, this is too hard, if you're not getting it right away. Just keep going and take it in bite-sized chunks. And it will improve your object-oriented code too. So things that you can do to start integrating these techniques in your Ruby code, try to avoid mutating data. Most Ruby functions are, and this is another thing I love about Ruby, most of them have the bang sign on the end if they're going to mutate the original. So you can usually tell by looking at what it's going to do, and I love that pattern. There are a few exceptions to that, like the push that we looked at earlier, but for the most part, that follows. So try to avoid mutating data when you don't need to. And then also, try to avoid side effects and global state. If you're not using the return keyword in your method, that can be an indication that you're probably causing some sort of side effect. And so that's definitely something to pay attention to if you're not using, or implicit returns, right? So try to use modules more instead of classes. And then in your modules, try to focus on transforming data rather than objects. So that doesn't mean, like if you've got some user model, for example, that doesn't mean that you have to write, some module that's, something strictly, you can still write a module called user. And then in that, it has functions that operate on a user object. But the difference would be that you pass that user in and it doesn't mutate it. And it's not invoking methods on the user necessarily. That's a bad example. Don't listen to me. One word of caution, though, keep it Ruby. Don't go crazy, because your coworkers are going to hate you if you start using these crazy styles that they have no idea about. It still should be idiomatic Ruby. Otherwise, you're going to create yourself a mess. So which is better? Right, this is the ultimate in debates. I'm actually going to say it depends. There's probably diehard functional guys out there that think I'm a traitor right now, and it's understandable. But I honestly believe that some applications are a lot better with a functional approach, and some are better with OOP. For example, and I'm not a functional programming wizard by any stretch, but when dealing with very big nested data structures like hashes and JSON and stuff like that, I find the functional approach to be a little bit difficult because especially when some piece way up here depends on some piece way down here, and you need to change them and stuff like that, then it can get pretty hairy. There's different ways to approach that, but it's certainly not as straightforward as just using Ruby and mutating the data right on the spot. And sometimes that mutation is way more clear what you're doing. But again, try to keep it together. Try to make it obvious where the mutation's happening. OK, so enough about the abstract theory. Let's talk about some actual code here. So the basic types in Elixir many of them are exactly the same as Ruby for the most part. Like integers, it's the same. I mean, the column on the left, that's Ruby and Elixir code. It works in both. So you can see with integers, you can just declare them literals and base 10, just like you expect. You can also declare them in hex or octal, and also really cool, which I would have loved back in the day when I was working on a network stack, is the ability to do a binary literal, which is very cool. And then floats, obviously, you can use the point something something E5 scientific notation, and that works just fine. And then ranges are there in Elixir, just like Ruby. Then we have atoms, which are basically Ruby symbols. And there are minor implementation differences, but for the most part, you can think of them as the same. And syntax is as you'd expect. Then we've got regular expression literals as well. These are PCRE, just like Ruby. And the syntax is slightly different because we're actually using Elixir sigils, which I'm not going to get into. But it's pretty darn close to Ruby, so it's really not difficult to adapt. Basically, there's this squiggly R in front of your slashes, and then it's Ruby. So let's talk about strings, because the vast majority of applications are not useful without some sort of strings, particularly in the web. So strings are a little bit different in Ruby, but most of the time you can think of them the same way. Strings in Elixir are all UTF-8, and they support the normal escape sequences that you would expect, like \n, \t, etc. But there's basically two different types, and an Elixir purist might cringe as I explain this, but essentially you can think of them as single-quoted strings and double-quoted strings. In Ruby, they're basically the same except for interpolation, but in Elixir, they're actually very, very different, and there's important reasons. Single-quoted strings in Elixir are actually character lists under the hood, and lists in Elixir are linked lists, just like in Lisp. So what that means is that all of your list and enum module functions will work. You can iterate these things just like you would an array or a list, and it will all work as expected, but they are a lot less efficient to work with. If you think about a linked list where every character is essentially one link, that can get really unscalable really fast. So most of the time, you're going to want to use double-quoted strings. Under the hood, these are Erlang binaries, which is a fancy way of saying they're like arrays in C, for example. They're actual contiguous memory bits, and they're just Unicode bytes internally. They're called binaries, which can be a little bit confusing, but that's really all they are. They're more like C arrays. This makes them a lot more efficient to work with, but the key is you have to use functions that are made to operate on binaries instead of lists, otherwise they won't work. But the good news is there's a string module which implements basically everything that you should need. And so if you find yourself implementing something by yourself, that may happen, but for the most part, you won't need to. But with Elixir, just use double quoted. Unless you have a good reason to use a single quoted character list, you just want to kind of default to the double quotes. So let's look at some quick examples. This uses the string module, and in Elixir, we always invoke things as module.function. And then the pattern that they follow is the first argument is usually whatever would have been the object that you're dereferencing before. So if you used to would do some string .at and then pass an index, now you're going to pass that string as its first argument. And there's a reason why we follow that pattern, which will make more sense when we get to the pipe operator in a minute. But once you know that, it's pretty straightforward to use. This mostly looks like Ruby. And you can see that it does what you expect. Now in this case, I'm passing a string literal, so it's not going to mutate it. But even if this wasn't a literal, I can know with assurance none of these functions are going to mutate my original, which is an awesome guarantee to have. So lists in Elixir are basically arrays from Ruby. So you can see here we created a list called ages, slap a few integers in there, and then we can call functions and pass that in. So enum.reverse, enum.sort. The enum module is useful for any sort of data structure that you can enumerate, like maps and lists and stuff like that. But then there's also a list module for things that don't make sense necessarily in a map, but make perfect sense in a list, like the pop at and replace at and things like that. So pretty straightforward. And also, I must say, the documentation for Elixir is phenomenal. It is really, really good, very approachable, so it's very easy to find what you need. So there's kind of a newer type called a tuple that's not really a thing in Ruby, but don't worry about this too much. It looks a little bit weird, but they're basically just meant to be fixed-size containers for multiple elements. And they're not meant to be enumerated at all. They're basically sort of like the binary, if you will, but they're mostly used with pattern matching as a way to return multiple values. Because again, we're not allowed to make side effects, so you're going to find a lot of functions will return multiple values because there's no object to stuff those things into. These are super efficient, which is why they're used so widely. But again, if you're going to need to enumerate this, or if you're nesting it pretty much at all, do not use a tuple, because you will hate your life. So maps. Maps are basically the hashes from Ruby, and it's essentially the same syntax as Ruby. We're just slapping a % sign in front of it. And the reason we do that is because if we didn't, this would be a tuple, which obviously is not what we want. So you can see maps pretty much behave like you would expect. They've got, there's a map module. It's got a has key and a keys and values, and very, very similar to Ruby. Blocks. So blocks are used a lot in Elixir, even more so than in Ruby. For example, you can see in this, we're defining a module called hello and a function called world. And so you can see the way you declare a module is def module hello. And then you can see there's a do after that. So we're actually passing the entire module's definition as a block. And then when we define the world function, we're passing its code as a block again. But you can see it looks a lot like Ruby. We're using the IO module, so we call io.putString, which does exactly what you'd expect. And you can see parentheses are optional here as well. They are heavily encouraged in Elixir, though, so I tend to leave them off for things like putString and stuff like that, but for the most part, you probably do want them. But string interpolation works just fine, just like you'd expect. And then we can invoke this new function we just defined with hello.world and then some string. And you can see here, I gave an example of how you can essentially write a script. So where you've got your shebang at the top, and it used to just say user bin env Ruby. Now it just says Elixir, and this works just fine. Now there is some overhead, because this has to go through compilation and stuff. So if you want it to execute immediately, then you need to either pre-compile it or use Ruby. There is a simpler syntax for one-line blocks. Because it's functional language, we emphasize short functions. A lot of times, our function is only a single line of definition. So there's a simple syntax for inline blocks, which is essentially slap a comma and then a do with a colon on the end, and then your line of code. And it works just as you'd expect. So let's talk about pattern matching. This is something that can be difficult for object-oriented people to grok, and it certainly was for me. It took me working through several examples and really thinking about it. And then at a certain point, it kind of clicked. And mostly I credit Dave Thomas for that, for writing an excellent book, which I will recommend at the end of the slides. But to understand pattern matching, it's really useful and really helpful to examine what the equal sign means. Equal sign in Elixir does not mean quite the same thing as it does in Ruby and C and Java and many of the other languages that you're probably used to. But it often behaves the same. But the subtle difference in behavior is important, so that's why we're going to talk about it in depth. You can see here, well, so first, in Elixir, the equal sign is not called the assignment anymore. It's actually called an assertion. In fact, we often refer to the equal sign as the match operator. That's a pretty interesting change. So let's look at the first line here, age equals 23. This does exactly what you would expect it to do. But then on the next line, we do something in Elixir that doesn't make any sense in most languages, but it makes perfect sense in Elixir. We say 23, the literal constant 23 equals age. Elixir cannot change that left side value or variable. It is a constant. You can't change the constant 23. The entire world would burn down from math. So, but obviously Elixir is fine with this. It has no problem. The reason why is because Elixir just tries to make both sides equal, just like you would expect from math. So in math, when you were doing algebra, you had an equation, and there was an equal sign there, and that basically meant both of these sides will evaluate to the same value. That's the same thing that it means in Elixir. So the equal sign is actually more mathematical now in Elixir than what you're used to. So 23 equals age is no problem for algebra. Same, it's no problem with Elixir. But there is a slight difference. On the last line here, we do 25 equals age, but we already said age was equal to 23. So this can't happen, because Elixir is not going to try to change the value of a right side. It only tries to change the value of a left side. So it looks and says, oh, the constant 25, I cannot change that to meet or match age, which is set to 23. So I'm going to raise a match error. So in Elixir, when you're first starting, you're going to see a lot of match errors. This is what it's talking about. Your pattern match failed. Don't get too lost by the different terminology. Okay, pattern matching also works on lists. You probably already use this and maybe don't even realize it, because this is how most destructuring works, like in JavaScript, for example. It's the same idea here in Elixir. You can define a pattern, and Elixir will try to make that match. So the first line here, we just create our ages array. And then we do something totally weird. We have two array literals that are identical, and we set them, we have the equal sign, and that is perfectly fine in Elixir again. It's an assertion. Keep that in mind. It's an assertion, not an assignment. Then on the next line, we have an array of A, B, and C, and we try to set that equal to our ages array, and this works just fine. And you notice the way Elixir made this work is it set A to 18, B to 23, and C to 25, and everything worked just fine. Then we do it again with a totally different array, and it works just fine. You can see A, B, and C are updated. Now, if we flipped the arguments and we changed their sides, that would fail. But I didn't put that in the slides. Okay, maps. So pattern matching works just fine in maps too. In fact, as I started getting used to pattern matching, I got to a point where I realized pattern matching is by far my favorite way of grabbing values out of data structures, at least simpler data structures. You can imagine if this map was nested 10 levels deep, pattern matching would be an absolutely horrible way to do it. But when it's a shallow map or a shallow list, pattern matching is an amazing way of getting values out. Okay, if pattern matching was only for the equal sign, it would be cool, probably a little gimmicky, but it's not. Pattern matching is also used for invoking functions. And this is where its real power comes in. Destructuring is a great feature, but the ability to invoke functions on patterns is what I think is, like there's really two features of Elixir that I love. I can't choose the best, but pattern matching and the pipe operator are definitely there. Also, breaking news yesterday, we might be getting pattern matching in Ruby, which would be fantastic. But anyway, staying on topic here. So I mentioned that functions can be invoked based on pattern matching. So essentially what this means, it's a lot like function overloading in, say, Java or C++, if you're used to that. You essentially define a function with the same number of arguments. In Elixir, we call that arity. It's a fancy word. It just means number of arguments, basically. And if there's two functions with the same arity, then Elixir will look at each of them in order of declaration, and find the first one that matches the pattern, basically the first one where that equal sign would succeed. If you don't get a match error, that means it succeeds. It will find the first one that matches, and then it will invoke that one. As I mentioned, you kind of specify a pattern in the argument list, and we'll take a look at that here. Key to remember, if no candidate matches, an exception will be thrown. So that is basically how you can see, oh, none of my functions matched. So here's an example. Factorial is like it's like the hello world of functional programming because it's a naturally recursive problem, which works very, very elegantly in functional languages. So no exception here. I define a module called factorial, and then there's two methods. You notice they have the same arity, which means same number of arguments, and they're both called of. The first one defines a function of, takes an argument of the constant 0. That would make no sense in a language like Ruby. You would never do that. It makes perfect sense in Elixir because it only matches the constant 0. So in other words, we don't need any if statement in there. There's no logic. There's no branching. It just magically works like you'd expect because if this function is invoked with 0, it'll return a constant 1, which is obviously our base case in our recursion, so that means we want to terminate the recursion. Then the next line is what does most of the work. It just takes in an n, which matches everything. And it takes that n, and it tries to n times of n minus 1. Obviously not super robust. What if you pass a string? What if you pass a -1? Don't worry about that. We'll kind of cover that actually in the next slide, but not really. Not a great solution. Anyway, then here at the bottom, I just have this enum.each, and it prints out the stuff you see on the right. I wrote it that way intentionally because it will be more familiar for Rubyists, but it's not really idiomatic Elixir, so we're going to refactor that in the next few slides to be more idiomatic once we talk about the pipe operator. So what happens if we flip the order of definitions of our of function? So now the n, which matches everything, again, is on the top, and our of 0 is on the bottom. I'll give you a hint. It infinitely recurses because there's no base case anymore, because a literal 0 will match an n, and Elixir takes the first one. So it's going to take the first one every time. It's going to try to n minus 1 that, and that's going to get you to a -1, and from there, you're off to the races until you overflow the stack. Elixir will totally warn you. At compile time, it'll say, hey, just so you know, couldn't match this one thing because there's a blanket pattern somewhere. So this is probably not doing what you think it's going to do. It is a warning. You can proceed if you want. I would not recommend it. So let's talk about the guard clause. Don't worry about the pipes on the bottom left. I ended up reordering the slides, and I was too lazy to fix the example at the bottom. So don't worry about it. We're going to explain it. So here's our factorial. It still has the n at the top, but we're using Elixir guard clauses. Now, don't overuse these. These are essentially ways of specifying more conditions that aren't easily expressible as patterns. So for example, we still have our of that takes one argument in n, but then we slap on a couple of extra conditionals, like when n is an integer and n is greater than 0, then this pattern will match. Again, don't use guard clauses first. Try to do it with pattern matching, but these guard clauses are there because Elixir, like Ruby, tries to be beautiful, and it succeeds. And it tries to be elegant. And if we didn't have guard clauses, I think it would be a nasty soup. So there you have it. So this actually fixes our code, and so now it runs like it did before. It's just not super great looking. So let's talk about the pipe operator. As I mentioned, this is also one of my favorite features in Elixir, probably tied with pattern matching. This essentially lets us write things in a much more palatable way. So I mentioned we're trying to build chains of transformation here. We're looking at, we've got some value, and we want to transform it into something else. That's kind of our base paradigm and approach with programming now in functional. So let's look at what that implies without a pipe operator. And I also say the pipe operator is really great for those of us coming from OOP as well, because it lets us think still in a sort of OOP way, which I think is really important. Because OOP is popular for a reason. There's a lot of value in that approach. Basically, all the pipe operator does is it takes the previous value, basically whatever value is on the left side of it, and it magically, syntactically sugarizes that into the first argument to the next function. That's all it does. So it's really not magical at all. So let's rewrite that bottom part to be a more idiomatic Elixir. So here's a more idiomatic way. Now we're using enum.join, enum.map, enum.map. We've broken it up into small, useful functions, and we're essentially blending those together. Now, if Elixir code looked like that, you would probably not use it, and neither would I. That's hideous. Nobody wants to see that. So how can we make that better? Well, obviously, the first thing we can do is add some white space. So now you can see it a little bit more clear, but it's still pretty gross. Like, imagine if you had a pipe that's 10 functions long. You're back to the Node.js callback hell that tortured us all for a little while until we learned how to use promises properly. And async and await now, which is even better. But so this is more idiomatic Elixir, like I said, but it's still not great. This is where the pipe operator will save us. Using the pipe operator, we can break this down into a much more functional approach, and it's now a very readable transformation chain. So we start with a range, 1.6, because we're trying to print out the first 6 factorial, and then we just run a map on that. We map it to a tuple of I, so that we know what the original value was, and we map that to factorial.of of I. So that tuple comes back, and the pipe operator will magically make that be the first argument to our next enum.map function, and we pattern match on that tuple, so we can extract the I and the factorial, because that's what we're interested in, and we map that to a string. And then that goes back. Pipe operator, again, passes that as the first argument to enum.join. We join it on a \n, so that we've got our nice formatting, and then that will be a single string value, which we then use the pipe operator again to pipe to io.putString. Much, much better approach. Okay, let's look at some of the tools in Ruby and their equivalents in Elixir, because again, there's a lot of similarities. So if you love the Ruby ecosystem like I do, then chances are you're also going to like the fact that Elixir has a lot of equivalents. So IRB, the venerable interactive Ruby, there's an IEX, interactive Elixir, which does exactly what you'd expect. The IEX is a little bit more powerful. It's really more like a combination of pry and IRB, but that's not a perfect analogy. You have to kind of try to get to some of the pry features, but anyway. Then Ruby gems, the gem tool, there's an equivalent called hex. Bundler is replaced by a tool called mix, and same with rake. So the bundler and rake is probably the more Unixy way to do it, of have something small that does one thing and does it really well. But mix takes the place of both of those and basically behaves like you'd hope. So that's a whirlwind tour to Elixir. Let's talk about Phoenix. So Phoenix is a blazing fast, highly scalable Rails-like framework for Elixir. You will see it really is very Rails-like. If you already know Rails, you know quite a bit of Phoenix already. And what you don't know is going to be pretty intuitive, with a few exceptions. The biggest thing for me, I built a little throwaway app in Phoenix, just kind of get an idea about it. And I noticed my response times that were being printed out were in microseconds instead of milliseconds. That was indication number one. Holy cow, performance is insane here. And there's a few reasons why. We'll go into that. But many times, your response time will be under a millisecond. So if they didn't use microseconds, they'd be rounding to either 0 or 1, which is pretty mind-blowing. There's also some proofs of concept out there that Chris McCord has built, for example, that they have so many connections, so many concurrent WebSockets hitting this Phoenix server that you start to run into the U-limit of Linux. Like, your operating system stops scaling before your server does, which is kind of awesome and terrifying at the same time. So there's a simple example project. I actually planned on writing one specifically for this talk. I ran out of time, and so I just grabbed a little microservice that I wrote a little while ago, and so you're welcome to look at that if you want. The code samples in here come from that, but I'm not going to really explain the app because it's kind of out of scope, and I apologize for not having something better for you. But yeah. Okay, so I said that Phoenix was super fast. That deserves some backup and some proof. So here's some benchmarks. Now, let me first say I don't trust pretty much any benchmarks because they're so easy to game, and they're usually trying to measure the strength of whatever you're trying to prove is blazing fast, for example. So metrics, take them with a grain of salt. And also, these metrics are from Phoenix 0.13. We're up to version 1.4 now, so they're kind of outdated. But these were the best ones that I could find, and I think they do a decent job at sort of illustrating the thing here. So you can see plug is at the top, and Phoenix is actually built on top of plug. And Phoenix itself adds a little bit of overhead, as you would expect, but not a ton. And it actually adds more consistency, which is kind of interesting. But then we've got Gin, Play, an older version of Phoenix, Express, Martini, Sinatra, and Rails. And you can see we're talking orders of magnitude faster than your standard Rails setup. So that's a huge performance. Oh, really? Oh, man. OK. Thanks. Better hurry this up. So what makes Phoenix so scalable? OK, I mentioned that it's built on top of the Erlang VM, which means you've got full access to the actor model. Long story short, the Erlang VM was built by the telecoms to run on switches for phone companies. So it had to be rock solid, and it's benefited from decades of that. The key to horizontal scaling is multi-process, as we kind of talked about. And in Elixir and Erlang, that becomes pretty easy, even for noobs. Phoenix also fits really nice into existing architectures. So here's another look at a Phoenix live view. This one is a server-side rendered clock, which is cool. So let's talk about some of the major Phoenix components. Routers, controllers, views, templates, and then we have now something called channels, and then Ecto, which is basically like Active Record, but it's probably the most different part. The Phoenix router is built like a pipeline, just like you'd expect from a language that emphasizes transformations. So it uses the underlying plug library, but the Phoenix router is very declarative, just like in Rails. So here's an example. This is the router, and we've got two pipelines. One's a browser, one's an API. If your microservice or your app only uses an API or only offers an API or only browser, vice versa, then you don't need this. But this one has a UI portion, and then there's a curl script that hits the API endpoints. So that's why there's both. But you can see it's very easy to lay out how things happen. So in a browser, we want some more middleware that we don't care about for API calls, like cross-site request forgery protection and secure browser headers, et cetera. Then we've got a few endpoints. You can see it's pretty much like the Rails router with get, resources, post. Just like you can do rake routes and CU routes, there's an equivalent for Phoenix, phx.routes. So controllers basically do what you'd expect. It's part of the request pipeline. It gets invoked by the router. And the difference is you take in a connection, and I use the word object lightly. It's basically a map or a struct kind of thing. But you take in a connection map, and then you essentially add things to it. So you transform it by adding things like your response codes and stuff to it. And then Phoenix takes care of converting that into HTTP. Usually you're making some sort of database query, do some logic, or render a view. So here's a slightly more, slightly bigger controller, but obviously not big. This basically uses, there's a little piece of middleware that pulls the user's information out of the database when they first make the request. And so if it's there, then I redirect them to the page they really care about. If not, I just send them back to log in. This is a session controller. So basically, it's how you log in, you create a new session. Just a few actions here, new, create, delete. Pretty straightforward. But what you might notice right away is there's a lot of pattern matching in here. And that is by design. Essentially, we really reduce and eliminate the need for if statements and with pattern matching, which can be really nice. This is slightly more complex. This is a user controller, so you can see it's got a few more actions. But for the most part, it basically just sort of declares what you want it to do. Render some template, or render some view, and grab some data from the database, that sort of thing. So a view is basically a module that just contains rendering functions. The key takeaway is that it's the view's job to render something. If it's just JSON, that's fine. If it's HTML, that's good too. Sometimes it'll do a little bit more, but there is a difference between views and templates. Templates are basically embedded Elixir, or EEX, which is basically the same thing as ERB. These are super fast in Phoenix. This is one of the ways, this is one of the ways that we get response time super low, is internally they're linked lists instead of strings, which helps a lot. OK, so this is a template. You've seen those many times. Channels, super cool thing about Phoenix. They're basically stateful conversations. So the old request response thing where HTTP being a stateless protocol, we hack cookies and stuff in there. We don't need that anymore. So we actually can oftentimes do away with cookies and maybe even the database. If you're keeping session information in Redis, for example, you may not even need it anymore. These can be implemented with either WebSockets or long polling, or you can build your own protocol, which is really cool. But Ecto, this is actually the last section here. So an ORM for Elixir, we're not going to go into it. I wasn't planning to anyway, but it basically uses macros, which are like Lisp macros. And so the DSL is really cool. It's a lot closer to SQL than Active Record, for example. You can see migrations here. They pretty much look like they do in Rails for the most part. Here's one that's actually related. You can see we've got our has one and a belongs to, just like you would expect from Rails. So pretty straightforward. And then this bottom one is an actual query. So you can see there's a from function that's defined, then we pass in some code, which the DSL will translate into SQL, but it's a lot closer to SQL. And it also only responds or returns data you explicitly request. So no more accidental .stars and things like that. Deployment is very simple with Elixir, just like it is with Rails. Heroku is going to be your best experience, in my opinion. There's build pack for Phoenix, and there were a little bit of bugs earlier on, but they've made rapid improvements. And it was a third-party thing. It still might be, but Heroku, the guys from Heroku actually get on the GitHub and send pull requests and give advice. So they're definitely helping out, which is freaking awesome. It's exactly what you'd hope from a platform as a service. Gig Elixir is also one. It actually supports a little bit more than Heroku, but it's a little bit more expensive. And then if all you want to do is just slap a Docker container, you can do that easily because Cowboy is like the server that comes with it, and it's production ready. Or you can go all out, which we're not going to cover. Will Elixir replace Ruby? No, I don't think so. Ruby's always going to have a place. It is by far the best scripting language, and it's also great for prototyping. And most applications are constrained by big O mistakes, not by performance. So happiness probably matters more. Developer happiness is a huge constraint. That's basically it. There's some advice for further things if you want to read more. And these are 2 excellent books that you might want to check out. The Dave Thomas book on the left, the Chris McCord one on the right. It's actually an early release, but it should be out soon. And here's some more stuff. And if you want to contact me, there's my information. That is all.